Thank you for joining us, and welcome to today's lesson on design thinking. My name is Michael, and I will be leading you through this introductory series. In this session, we're going to learn the fundamentals of a creative problem-solving methodology that will help us come up with innovative solutions to problems. Don't forget to like and subscribe. Design thinking has its roots in the fields of design and engineering, but it's been adapted and evolved over the years to become a powerful problem-solving methodology used in a variety of fields. It was popularized in the 1990s by David Kelly and his team at the design consultancy IDEO, and since then, it has become a widely used and recognized method for innovation and creative thinking. Today, there are a wide range of methods and a number of different depictions of the process, but the fundamentals still remain the same. As part of this series, we will take a brief look at some of the different versions. But for this pack, we will be primarily focusing on the Design Council's Double Diamond, first introduced in 2005. This framework allows you to bolt on different techniques to aid and support the process, tailoring it to your specific context. There are several variations of the design thinking process, each with its own approach and methodology. Some of the most well-known variations include IDEO's design thinking methodology. This is a human-centered approach to design that emphasizes empathy, experimentation, and iteration. Stanford Design School's design thinking framework. This framework focuses on the 5 stages of empathize: define, ideate, prototype, and test. The Double Diamond design process. Developed by the Design Council, this framework focuses on the stages of discover, define, develop, and deliver. Design sprint. This is a fast-paced, 5-day take on design thinking that helps teams solve complex problems and test solutions in a short period of time. Lean design thinking. This approach combines lean startup methodologies with design thinking principles to create a faster, more iterative perspective to design. For this series, we will be talking about the Double Diamond. If you are interested in design sprints and lean design thinking, this will be covered in another set of courses on my Patreon page. These are just a few examples of the many variations of the process. The choice depends on the problem being solved and the needs of the situation. Some organizations may prefer a structured, step-by-step procedure, while others may tend towards flexibility and agility. The key is to find the right toolset that works best for you, the team, the client, and the problem being solved. Before we go any further into the design aspects, we must first understand why design thinking exists in the first place. To do that, we will need to revise a mindset many of you will have learned about at school called the scientific method. The scientific method allows humans to learn about the world around them and discover new answers to challenging questions. In simple terms, it's like playing a detective. Here's how it works. First, observe a phenomenon or problem and gather information about it. Imagine a scenario where you notice that the plants in your house are not growing very well. In this case, you would ask yourself a simple question to help you start to explore the problem. For example, why are my plants not growing very well? From this question, formulate a hypothesis. One hypothesis could be, are they getting enough water? To test this, you would run an experiment to validate your guess. Give one group of plants a higher volume of water and another group a smaller amount. From the experiment, you should record any data and insights as you go. This will allow you to review and analyze the results and determine if there are any trends and patterns. You can then make conclusions and discuss the results with others. If your guess was right, then the conclusion is more water. If it wasn't right, or you want to add another variable, for example, fertilization of the soil, then iterate the process again until you have your desired result. The scientific method helps us explore novel situations and test theories, using experiments, observations, and the recording of data to spot patterns and trends in a systematic way, either supporting or disproving our ideas. It's like solving a mystery, and it helps us learn more about the world around us. We can apply this same thinking in design. But the scientific method alone is not sufficient. We will need to extend the concept to include divergent and convergent thinking. These two frames of mind can be utilized to bring human creativity into the scientific procedure. Divergent thinking is a creative and open-ended process that involves generating a wide range of ideas and possibilities. It is all about exploration and generating as many ideas as possible. During the divergent phase, there are no restrictions, and all ideas are welcome, no matter how wild or unconventional. Convergent thinking, on the other hand, is a more focused and structured process that involves sorting, scoring, and narrowing down the ideas generated, selecting the most promising ones to move forward with. This stage is all about evaluating, selecting, and refining the best ideas into solutions that solve the problem. In design thinking, divergent and convergent thinking work together to create a balanced and effective approach to problem solving. Divergence allows for exploration and creativity, while convergence ensures that the best ideas are selected and refined. By alternating between divergent and convergent thinking, you can ensure that you have a comprehensive and well-rounded solution to the problem. Additionally, the scientific method adds rigor to the problem-solving process by creating structure and recording empirical evidence to support decision-making. The benefits of integration are numerous, including a balanced problem-solving approach that matches exploration and experimentation with evidence and logic. This vitally is important because if you want to plan well, you need to have a layer of consistency to come back to. The Design Council double diamond model is based on divergent and convergent phases, with 2 diamonds representing the different stages of exploration and refinement. The first diamond represents the problem space, where we empathize and define the problem and surrounding context. The second diamond represents the solution space, where we ideate, prototype, test, and deliver potential concepts, solutions, and products. Recognizing that the 2 diamonds have different focuses is key to remember as we move further into the series, as the approach for each is different. To give you an idea of how the double diamond process can be scaled, you can break the 2 diamonds down into 4 stages: discover, define, develop, and deliver. Discover involves divergently exploring and understanding the problem, customer, and context. In the second stage, define, we utilize convergent thinking to refine a process down into themes, insights, and problem statements. In the solution space, development is focused on divergently creating new ideas and concepts through ideation. The deliver phase is then focused on prototyping/testing to refine the concept according to our defined customer and context, bringing the solution into fruition. This series will progressively build into the detail of this process and how it provides the foundation for a scalable problem-solving framework which can be applied to any situation. Thank you for tuning in to the Contemporary Craftsman channel. We hope you found our video on design thinking informative and helpful. In this session, we've learned that all versions of design thinking stem from the scientific method and how divergent and convergent thinking can add a creative touch to the process. We also gave you a sneak peek of the Design Council's double diamond, which combines these elements into one powerful problem-solving tool. In the upcoming weeks, we'll be diving deeper into the double diamond, showing you how to use the right tools to minimize effort and maximize the value of your problem solving. If you have any questions or if there's a specific topic you'd like us to cover, drop a comment below. Don't forget, if you found this video useful, give us a like, share, and hit that subscribe button for more educational content. Until next time, take care and keep learning.